I've never actually worked these problems out, so I hope they're correct. I hope I didn't. It's sometimes when I go from a document and change it into another document, I forget to like change names or numbers sometimes don't work. So please, let's hope this works. And if there's mistakes, then we'll remedy them, and then I'll know what to fix throughout the rest of the day today. So again, this is your word problem review number 2. And I don't think time's going to be a problem. Um, if we can't do this as a team in one class period, I can't realistically expect you to take the quiz in one class period. So I think we'll be fine. So this is number 1. What's our first thing going to be? Yeah, let x equal the number, right? So let x equal the number. And so these are simple problems, just single simple variable declarations. And then we need to write an equation. What's that equation going to say?
X equals 2x minus.
Are you on the thing that says word problem review number 2? Okay.
X equals 3x.
There you go. So 5 times the number is the same as 22 more than 3 times the number. Very good. So step 1, done. Step 2, done. How would we solve this equation? Well, I mean, I know we have to do the equation.
So minus 3x.
There you go. We have to subtract 3x from both sides, which gives us 2x's over here. And then we divide by 2, giving us x equals 11. So steps 1, 2, and 3 happen quick on a simple problem like this. And then remember, for step 4, you have to actually answer the question and say something like, the number is 11. So whenever I write anything in yellow over the course, well, you know this from the last 2.5 weeks, that the yellow is like a statement of we're done, right? That's my final answer. Everybody got that? Any questions on number 1? All right, let's do number 2. Let's begin with a variable declaration. Who would be our x? Good job. X is definitely going to be the smaller number in this case. What then would be the larger number?
2x minus 11.
Good job. Let 2x minus 11 equal the larger number. As you're getting this onto your paper, make sure you're mentally a part of the process. Like, you're not just copying things down, you're thinking like, yeah, that makes sense. That's what I would have done. And if you're not sure, just ask, right? So step 1, done. Step 2 is to write an equation. What's our equation going to say?
X plus 2x minus 11. Equals 28.
Right. So smaller number plus larger number is 28. And we know that because it says in the problem that their sum is 28. We'll quiz tomorrow. Okay, we're just doing another review today. We're doing it as a class, obviously. And then, as Bryce so eloquently put it a while ago, do the equation. So we have to combine like terms on the left, giving us 3x. What do we do after that? At 11, giving you 39. Divide by 3, what do you get? X is 13. Now, you remember, you have to be mentally in tune with this. That is the smaller number, right? And so the problem doesn't say to find any one of them in particular. It says, what are the numbers? So we would say something like, smaller number is 13, right? And you can use complete sentences for problems like this, or you can format it a little bit differently. It's up to you, as long as it's communicative and clear. What's the larger number? And how did you get that?
Double 13 minus 11.
Right. Just go back to this. I'm going to put a blue bubble around something for you. Remember, that is the larger number. We decided that like 2 minutes ago. And so you just put your answer for X in there. And 2 times 13 is 26 minus 11 is indeed 15. And so that's your boxed final answer right there. Any questions so far? So on the quiz, there'll be 2 problems per page. So you'll have tons of space for this entire process. So I won't want you to use separate paper. You won't need to. Put tons of room. We good so far? Okay. Question 3. What are we going to declare as our X here? For sure, the notebook. And so let X equal cost of notebook. And then from there, you just have to, you know the drills. Your first rodeo, you got to declare all the other things now relative to what you know. So how much, say, would a ball cost her? So we're going to let X plus 1 equal the cost of the ball. And then finally, we need to declare the cost of the game. And what would the game be? Yeah, twice the cost of the notebook, so 2x, but then 1 less than that. So definitely 2x minus 1 would equal the cost of the game. You guys have any questions about that? Okay, so step 2 is to write an equation, and the equation comes from the very beginning of the problem. We know that Marla paid $28 for the whole shebang. So what's that going to look like?
X plus X plus 1 plus 2X minus 1 equals.
Very good. It's just a very literal interpretation. I'll put little underlines under them. There's the cost of the notebook. There's the cost of the ball. There's the cost of the game. And we know from sentence 1 that when we add them, we get 28. So when we do a little bit of math on the left-hand side, combining our x's, how many do we get? And then when you combine your plus 1 and your minus 1, what do you get? Yeah, there's nothing there, so you don't put anything, right? It just happens. Sometimes it happens that way. Sometimes it doesn't. If 4x is equal to 28, what's x? Of course. So now it's time to emerge, read the problem, and it says, how much did the ball cost? And the ball, I'll put a blue bubble around it for you. Remember, we decided, again, a couple of minutes ago that the ball was x plus 1. And so we want to, this is a good time to use a complete sentence because we're just saying one simple thing. We could say the ball cost how much? $8. So once you know your X value, remember, there's no limit to what kind of a question you could answer. I could say, how much would 5 games cost? And you just go put it in place of game, get an answer, multiply it by 5. You could do whatever you want once you know X. Everybody still good? By the way, these questions are very similar to the ones on your quiz. So like you want to talk about like which ones are good. Because remember the practice had like 13 or 14 questions on it. These are the 10 that will be on your quiz. Obviously different names, different numbers, different items, stuff like that. But you got these down, you're going to do great, like 100% great. Number 4, what's going to be our variable value here? And I'll just stay consistent and stay with X. It's fine. So let X equal the width. So this might be a good one, remember, where you could, in lieu of declaring your variables, you could draw a picture, and I'll do that here in a second. What would the length be? So if you wanted a break from this whole let X equal thing, if that really drags on you, then remember, you can always make a picture. You could draw an actual rectangle, and you don't have to do both. If you want to do both, well then great, but you don't have to. But in any kind of geometry problem like this, your picture can take the place of the declaration. So like you could just take and put your X on the short side and then your X plus 2 on the long side. And that can eliminate the need for those if you want. It's up to you. And now it's time to write an equation, and the equation is going to be based on the fact that the perimeter is 64. So what's that going to look like? Yeah. And as we've discussed on several occasions, there are more condensed ways to do that, more concise, perhaps. You could say, like, you know, 2 of the sides named x plus 2 of the sides named x plus 2. Or some people do it another way. Some people say there are 2 packs of x plus 2. I mean, there's tons of ways. But really, what winds up happening, no matter how you slice it and dice it, all of this has to equal the perimeter, which is 64. Yeah. So at some point, no matter how you get there, you have to come to the conclusion that 4x plus 4 equals 64. You got to get there. And we'll all get there. I mean, no matter which of those methods of expressing the perimeter we decide we like best. And then we subtract 4. We get 4x equals 60. And then we divide by 4, and we figure out that x is 15. So step 1, we did a while ago. Step 2 was writing that big, beautiful equation. Step 3 is doing the math. And then step 4 is just to read the question. And the question says, what are the length and the width? And so I could say length is 17 centimeters. And the width is 15 centimeters. You know, if I'd only asked you for the length, then you would only answer accordingly. Remember, you should only box up what you claim is the answer directly to the question. But in this case, we were asked for both. Any questions so far? Okay, let's head on to number 5. Number 5 is another geometry question. I felt like there had to be 2 of these on here because we want to do a change problem. And so this is a really good problem to draw a picture on. I'm not going to budge on this one. So I'm going to start by drawing a rectangle whose length is twice its width. And so I want it to look proportionally accurate to match that. So there's a rectangle whose length is kind of sort of twice its width. And at this point, I'm going to put an X for my width. What would my length be? For sure. And now I'm going to make some changes. It says that the length gets decreased by 3. So when I make a new length, I want it to look a little bit shorter than the first length. And then when I do a new width, the problem says it gets increased by 5. So I'd like it to look like it got bigger by 5, like this perhaps. If your picture isn't proportionally accurate, that's okay. It'll still serve its purpose. How long is the new length, that new top side?
Oh, it's not.
Because it used to be 2x, but it got decreased by 3. So now it's 2x, you know, what it used to be, but minus 3, because it got decreased by 3. What's the new width? Right. Doing a problem like this without pictures, man, that's pretty hard, right? So I'm going to stick by this. 100% the best way to do this problem. Write down. No need to write down, let this equal this. We've already got it all covered. We're good. And it says that if those changes take place, the perimeter will be 68. And so we're not interested in this rectangle for the sake of writing our equation. We're interested in the rectangle that is post-modification. And so we're interested in this fellow over here. And his perimeter, we're told, is 68. So again, you can write it all the way out, like top plus side plus bottom plus other side. I mean, you could do that, or you could say like 2 of the tops plus 2 of the uppy downy sides. We hope we all agree that's a good way to say perimeter, right? That accounts for all 4 sides. If you put all that together, you'd get the perimeter, which is 68. And as any math teacher will tell you, that's the hard part. The rest ought to be basic. Doing the equation, right? As Bryce again said, distribute, combine like terms. You know what to do. So when I distribute, I'm going to get 4x minus 6 plus 2x plus 10 equals 68. Six x's, yes, and then plus 4. I agree with that. Equals 68. So I think I have probably found my first little error when I was whipping these up this morning. I was hoping things would come out to whole numbers, but this happens and it's okay. It won't happen on the quiz, I hope, but if it does, it's okay. Don't panic. We can do this. And so when I subtract 4 from both sides, you can see that something is going to happen that you're not really used to. 68 minus 4 is 64. And of course, 64 cannot be divided by 6. So we're going to get x equals 10. And listen, because again, this isn't something that's really going to happen to us, I would be okay if you used a really nice decimal for this. I would also like it if you did like a fraction. How much would be left over if 6 goes into 64 10 times?
4.
4 out of 6, right? Which is 2/3. That would make a lot of people really uncomfortable. I know that. And so if you wanted to be really mindful of that, you could also, if you like it better, say x equals like 10.67, right? That's like the rounded up version of that. So things happen. So now the question is going to ask us, what is the length? I'm not sure I like my grammar there. I probably should fix that. What are the length and width? Oh, never mind. It's a singular. What is the length of the original rectangle? So the grammar's okay. So the original rectangle, if x is 10.67 or 10 2/3, if I go back to the original rectangle, remember I have to put that right here where that blue bubble's at. That's the length of the original rectangle. So what would my length be for my original rectangle? Yep. So the length of the original rectangle is 21.3. I think, is that what it comes out to exactly? All right. Same thing, 21.34. Okay. So 21.34 feet. So not glad that I got a decimal there, but it's good for us to understand that it's not the end of the world, right? It's no big deal. The algebra isn't going to lie to us, so it's all good. Do you guys have any? Yeah, it actually would be even better. Yes. Because if we were to keep this as fractions, this would be 10 2/3, which if you double that, twice that, you get 20 4/3, which is 21 1/3. So the best answer would be 21 1/3. Yes. So, I mean, technically, that's why I was a little apprehensive when you guys said 0.34. But I understand why that comes out on your calculator. It's because of the way we rounded the first one. So it's all good. So sorry, not sorry for the decimal. Any questions on that one? All right, hopefully I can dodge any more issues here. We'll see, fingers crossed. Problem number 6. The sum of 4 consecutive integers. So right away, I don't even want to read on past that. I just want to declare my letters. What are they going to be?
X first, plus 1.
Right. And we know not to mess with doing the x plus 2, x plus 4 stuff because they're just consecutive integers. And so to get from one to the next, we just add 1 each time. So x plus 1, x plus 2, and then finally x plus 3. And we would just do this for as long as we needed to to make sure we have enough. And in this case, enough is 4 because that's what the problem says. So what's our equation going to look like? Yeah, and there's Zane again, skipping steps, and I don't really want to do that, but I wouldn't mind if you did. I would know what you did. But for the sake of all of us in the room, let's write it out. So first number plus the next number plus the next number plus the next number. Oof, equals 42. I hope you can see that. That's just 4 integers being added together, consecutive integers. And then like Zane said a while ago, if you put all your x's together, you do get 4 x's. And then put together your 1, your plus 2, and your plus 3 for a total of plus 6. So you get 4x equals 36 or x equals 9. And the problem says, what is the largest of the 4? So clearly the largest of the 4 is where I'm putting this blue bubble. Obviously, that's going to always be the largest. And you put things in a row, the last one's going to be the biggest. So 9 plus 3 is 12. So we could say something like the largest integer is 12. If I'd asked you for all the numbers, you could say the numbers are 9, 10, 11, and 12, right? Everybody still good? Okay. Number 7. You feel right now if this had been a quiz that you would be acing it 100%? That's good. So number 7, we have 3 consecutives, but they're odds. So my first one is still going to be x. So let x equal the first integer. What's my second one going to be? For sure. Whether they're odds or evens, you've got to do plus 2 to skip to where you want to be. If x is odd, then by definition, odd plus 2 is the next odd. So x plus 2 is the second integer. And then what's my third one going to be? For sure. So step 1, done. Step 2, let's write an equation. It says to find 3 consecutive odds such that, now watch out, these are always a little bit trickier, and this is where I start to use words. It says 5 times the smallest. So it says the sum of this. So the sum of 5 times the smallest and, so I'm going to put a plus where it says and, because that's what sum is all about. So 5 times the smallest plus 4 times the largest has to equal 115. I'm trying to do this as if, if I were taking my own quiz, I'm trying to show you on each problem exactly what I think is the best way for you to get an A. And I think this is a good time to use words. When the equations get a little bit more complex, words are really helpful. So what's 5 times the smallest actually going to look like? Just 5x. And then 4 times the largest is 4, but right. So you're going to need parentheses for that one. Because if the thing that you're multiplying by has its own plus or minus, parentheses are huge. And this together equals 115. So, I feel like step 2 was sort of a multi-step process in and of itself. But technically, step 2 is right there. There's your algebraic equation. And now it's time to do the math. So I'm going to have 5x's plus 4x's plus 16 equals 115. Right. And then what do we do? So x is good. And so again, let's take a moment and read the problem. The problem says to find 3 consecutive odd integers. So this, so we can say the first integer is 11,
Is 13.
and the third,
50.
good job. So that's a good time to, I mean, again, complete sentences or not, just make sure your answers are communicative, clear, that they answer the question, all that good stuff. Still feel good? Yeah. Okay, so that's it for the consecutive integer problems. Let's head on now to problem 8. And I don't know what these things are. I'm just trying to come up with words this morning. I don't know what a dapper and a goober and a whomper are, but that's well beside the point. So first things first. Okay, so this is problem 8. Who should be our x?
Goober cost.
Yeah, you've seen this idea before. This is just a hamburger, hot dog, cheeseburger problem revisited version 3.0 now. And so starting out with kind of the middle one, I think is your safest bet here. So let x equal the cost of a goober. Who would we define next?
Dapper.
And how much is a dapper?
95 cents.
So in algebra class, that means x plus 95.
Yeah.
And that's the cost of a dapper. And this is always, man, I'd sure love it if by tomorrow, if I've got 100% of people on board with this. I haven't had this conversation with each of you yet, but I'm telling you, the key here is right now with your pencil, if you've never done this before, don't do this too hard because you're probably going to want to erase this, but start with your pencil on the problem right now. Do you see where it says 95 cents? And start scribbling out words until you get done with the and. I'm not kidding. Do it. Start where it says 95 cents and start scribbling stuff out. Trust me. And stop scribbling when you get to the word or when you're done with the word and. But make sure that you don't do it like obviously, hopefully you're using a pencil because you will probably want to erase this. But when you scribble all that stuff out, the first sentence now reveals something really important. It's a relationship that we might not have figured out. What does it say now? Right. And there you go again, kind of taking liberties. But so as to not confuse the masses here, to be quite literal about this, if you scribbled out what I asked you to, that first sentence now says a dapper costs $2.40 less than a whomper. And by eliminating that central information, you've now drawn a relationship between something that you know and something that you wish you knew. That's huge. I find that to be a pretty good strategy for you guys. And then Zane took some liberties and went ahead like he should, and he thought of the problem or that sentence backwards. And he said, well, if the dapper's 240 less than a whomper, then the whomper is 240 more than the dapper. Deep. So I'm going to write let blank equal cost of whomper. And remember, the whomper by definition is 240 more than a dapper. So I have to take my cost of a dapper. I'm going to put a little green comment here. I have to take this one and I have to add $2.40 to that. And that will reveal to me then the cost of the third variable. And what is, well, how am I going to do that? Right, so I'm going to do like x plus 95 plus 240. And I would obviously clean that up, and you probably will too. But that's what it looks like. That's the cost of the dapper, then increased by $2.40. You got to, one thing I've said before about this particular problem is you have to commit to either cents or dollars. You get in a lot of trouble if you said x plus 95 plus 2.4, because we got to say we're going with pennies or go with dollars. That's a lot of decimals though. So I'm just going to say everything has to be in terms of pennies. And so I'm going to fix this now. What is 95 cents plus $2.40? 335. So I'm going to go back Now change this to be x plus 335. That's that relationship that we might not have seen had we not scribbled out the guts, the central part of that first sentence. But we made it. And so having said that, now it's time to write an equation. And the equation, again, I'm going to use words, says that 4 Whompers cost $4.45. So that's going to be 445. Remember, we're committed to pennies here. Then 5 Dappers plus 2 Goobers. It doesn't take long to write that out, you know, but it's worth it. I'm 100% convinced that it's worth it. Time well spent. What am I going to put in place of where it says 4 Whompers? I'm going to put 4
times the sum of x and 300.
Good job. Is equal to 5 Dappers. So that's going to be 5 times. Good. And then 2 Goobers is just 2x. Good job. It's a lot of big numbers, but you know, that's what you come prepared to class with your calculator for. I don't think we've needed it yet at any point on this quiz, but numbers like this, I would totally support your decision to use it here. So we're going to do 4x plus, what is that? 1,340 equals 5x plus We're not scared of big numbers. Shouldn't be. And then it's time to do some math. So the worst of it is over. So I'm going to leave the left side alone. On the right side, however, I'm going to join my x's to make 7x's, and I'm going to join my constant terms, we call those, to make 920, I think. I'm going to check my math. And then I'm going to pull the 4x to the right because I like keeping my x's positive. If it were an inequality, I'd probably put it to the left. But with an equation, since I don't care about what side the x is on, I'm going to pull the 4x. Minus 4x gives me 3x. And then I'm going to do minus 920, which results in 420. And then I'm going to divide by 3 and get x equals 140. So it's like, yeah, whoop-de-doo. What did I just figure out? Yeah, so I now know that a goober, so I could make a little comment here and just say, okay, a goober is $1.40. Cool, but that's not what I was asked for. I was asked to find a Whomper, and so you don't even have to probably put that little comment that I just put. Since we're doing everything in pennies still, I'm going to go back up here to the beginning and I put a little blue bubble around what I care about. That's the cost of a Whomper. And if you and I know that x is 140, then you just put 140 where that little blue arrow is pointing. And what's 140 plus 335? Good. So at this point, we could finally answer the question and say a Whomper costs $4.75. And again, me using yellow is significant in that it signifies that is my answer. I'm not going to make my teacher sift through all of this stuff and choose. I'm going to declare to my teacher, this is the answer to the question that you asked me. And I'm going to put a box around it, make it even more awesome. Good, good. All right. And then 9 and 10 will, of course, be the age problems. 9 is an age change problem, and then 10 will be the number of years is what's missing kind of problem. So on 9, we want to let x equal what? Yeah, so let X equal Jen's age now. Remember to be specific. And then the other variable that we need is Marvin's age now. How old's Marvin?
6 years older than us, so X plus 6
Yeah, for sure.
is
So that's Marvin's age now. Because this is an age change problem, though, we don't want to stop at that. We want to declare a second package of variables. And it does say 8 years ago. So stop reading. And I've said this and I'll say it again and again and again. If you read past that comma, you'll probably miss the problem. At this stage in the game, I don't care what happened 8 years ago. I just need to go back in time and redeclare Jen and Marvin. So 8 years ago, how old was Jen?
X minus
She
2.
was X minus 8. So that's Jen's past age. Good. And then we also need to go back in time for Marvin. How old was Marvin 8 years ago? Now, see, you're reading past the comma, and you cannot do that. Yes, I'm telling you again and again and again. It has nothing to do with what's after the words 8 years ago. Nothing. Marvin is currently this old, X plus 6. But if we go back in time 8 years, we have to take away 8. And if you simplify that, then you get what Bryce said, which is X minus 2. So X minus 2 is Marvin's past age. So that's a step one that takes a while. And now we're going to use the green variables to write an equation. Now we can get ahead of that comma and say, okay, so tell me, what was true 8 years ago? And it says that 8 years ago, here we go. It says that Marvin was, that's an equal sign, 12 years younger than twice as old as Jen was then. I'm interested now. I've got all of the things that I need to go and put them in place. Now I'm interested. What are we going to put in place of Marvin?
X minus 2.
Yeah. Marvin's past age clearly labeled as X minus 2. You're fine. No need to be sorry. And then in place, we're going to put 2, and then in parentheses, what are we going to put for Jen? X minus 8. Now say it over and over. That's the hard part. The rest is just mechanics. Could teach a computer. You can't teach a computer to do what we've done so far, but you can teach a computer to do what we are about to do. And that's just muscle memory stuff at this point. So on the left, we have X minus 2, and on the right, we have 2X minus 16 minus 12. I'm skipping like no steps today at all. So thought that would be a good idea to show every little thing. I realize some of you at that point might have put 2X minus 28, and that's okay. But I'm going to do that now. So I'm going to have X minus 2 equals 2X minus 28. And then this equation is going to solve itself now really quickly. I'm going to pull the X across to the right, leaving me with 1X. I'm going to pull the minus 28 across to the left, but it's going to become a plus 28, which is going to be 26. So what did I just find? What is that? Yeah, and so the problem says, how old will Marvin be in 17 years? So I think a good idea might for me, I'm gonna write in blue. I'm gonna go up here and say, okay, so Jen right now is 26. Just gonna put some little comments off to the side. How old's Marvin right now? Marvin right now is 32. So interesting that the question says what it says, but as I've said before, you're armed and dangerous at this point. You're like, bring it. Ask me anything you want about these guys and their ages. I'll tell you. And so if Marvin is currently 32, how old will he be in 17 years? 49. So we can say Marvin will be 49 in 17 years. And that all stems from knowing X. X allows you to then say, bring it. I got you. Any questions on that? All right, then. The last one is number 10. So we're going to make it with tons of time to spare. This is good. Larry's 15. So I'm going to write that down. I'm going to write Larry is 15. And it looks like Merle is currently 61. Now it says in how many years, and so I'm going to make a variable here that says let x equal a number of years. So honestly, writing down Larry's and Merle's current ages, this part was kind of like meh, optional. Do it if you want to do it. But what's about to come is the important part. In the future, how old will Larry be?
15.
So we're going to say like let 15 plus x equal Larry's future age. That's a good way to put that. And then how old will Merle be in the future? So I say those top two that I've crossed out in white. I don't know, in hindsight, I probably didn't really need to do that. That was kind of silly, but whatever. But these are the important ones. These bottom three are the key. And now we're going to write an equation. And the equation says that in the future, we want Merle to be twice as old as Larry. And we've seen before, you've seen me mess it up. I mean, how much more proof do you need than if your math teacher can mess it up, right? I do this all day, every day. I can still make mistakes, but the words really help. And so I'm going to put Merle's future age over here, and that's going to be 61 plus x. And that's going to equal twice Larry's future age, which is 15 plus x, right? And then once we solve for x, we'll pretty much be done. We just have to answer the question outright. And again, this is a pretty quick, almost like a self-solving equation, just because of that relationship that you're going to see between the x's. There's 1 on one side and 2 on the other side. 2 and 15 make 30. And then here it goes. Pull your x to the right and get a single x. Pull your 30 as a minus to the left, and you get 31. And then write a sentence. You could say something like, in 31 years, comma, Merle will be twice as old as Larry. And that is that. So the rest of the time today, you've got about 8 minutes. You can ask me questions if you'd like to go over anything, or you can work on whatever you need. It's up to you. But quiz tomorrow, I won't move it again. I hope you understand why I chose to. Even if you don't, it is what it is. So quiz tomorrow, Tuesday, tomorrow.